Today I'm going to demonstrate how to solve for the roots of quadratic equations by factoring. Okay, so there's a lot of different ways that you could solve for the roots. There's a lot of different methods, but today we're going to focus on factoring because this is one of the main reasons that we learn to factor. Okay, because when we have a quadratic equation in factored form, it makes it really easy to solve. Find the roots using this method. You first have to ensure that your equation is set equal to 0. If it's not set equal to 0, you first have to fix it. Okay, but once it's set equal to the 0, you factor the trinomial or whatever the quadratic equation you have. And then once you have the factors, you just set each factor equal to 0 and solve for x. So let's see what the process looks like. Here I have x squared minus 6x plus 5 equals 0. So this first step is good to go. I don't have to fix it because it's already set equal to 0. So for this equation, I know that a is 1, b is -6, and c is 5. So because the leading coefficient is 1, it makes it really, really easy to factor. All I'm going to do is look for two numbers that multiply to +5, but add to -6. Okay. Some of you might do a t-chart. Some of you might use what I call the magic X. So when you have the magic X at the top, you put the C, and on the bottom, you put the B, the value of B, which is -6. So again, we're looking for two numbers that multiply to +5, but add to -6. Okay, so because my C is positive, I know that the signs have to be the same. And since the middle term is negative, then I know that both have to be negative. So it's going to be -5 and -1, right? These two numbers meet both conditions. So to finish off my factors, I'm going to have x minus 5, x minus 1. And technically speaking, it's all still set equal to 0. So now to finish finding the roots, we apply what we call the zero product property, which means that when you multiply two things, as long as one of them is 0, the whole entire thing drops to 0. And this is why you're able to solve the quadratic equation by factoring. So you're going to take the x minus 5, set it equal to 0, right? So we're in this last step, and you're going to solve for x. So we're going to add 5 on both sides to get x by itself. So that means that x equals 5. So that's one of your roots. But we have another factor, so that's going to give us a second root. Set that equal to 0 and solve for x. So here we would add 1 on both sides. So we end up with x equals 1. There you go. So you just factor, then set each factor equal to 0, solve for x, and these are going to be your roots. We also know that these can be called solutions, or zeros, or x-intercepts. Right? These are all the different names that refer to the roots, which is basically where the parabola would cross the x-axis, right? So 4 names for the same thing. Let's do another example. Let's say we have x squared minus 12 equals -x. All right. The first thing I check for is to make sure that it's set equal to 0, right? As we said earlier. This one is not set equal to 0. It's set equal to -x. So essentially, I want it to look like this: ax squared plus bx plus c. I want it to be in a standard trinomial form. So when it's not set equal to 0, it's really easy, guys. You just take whatever term is on the wrong side and you just move it back, okay? You just have to remember that when you go across an equals, you have to change the sign for the term. So this -x, when I move it back, it's just going to become +x. And so that it's in this right form, the standard form for the trinomial, I'm going to put it here in the middle. So I'm going to have x squared plus x minus 12 equals 0. So now that it's in standard form, I can factor. A is 1, B is 1, C is negative 12. So I'm going to use my magic X to find the factors that work. I'm looking for two numbers that multiply to negative 12 and add up to 1. That's pretty easy. 4 and 3 is going to work. It has to add to a positive 1, so I got to keep the bigger number positive. So 4 and negative 3. So x plus 4, x minus 3 equals 0. So now just take each factor, set it equal to 0, and solve. X plus 4 equals 0, so x equals negative 4, right? We subtract 4 from each side. So there's one of my roots. X minus 3 equals 0. Add 3 to both sides. So x equals 3. All right, and I'm done. I'm going to do one more example, and then we'll be through with this video. All right, so for example 3, we're going to do 7x equals negative 3x squared plus 6. All right, so it's not set equal to 0, so I need to fix it, right? I could easily take the 7x and move it over here, but notice that my x squared term is going to be negative. And what we've learned about factoring is when you factor, you always want to keep your x squared positive. So instead of moving the 7x, I'm going to take this entire expression here, the 3x squared plus 6, and I'm going to move it back. Because when I move it over, the x squared term, once it goes across the equals, it'll turn positive. So it's going to avoid having to do the GCF of negative 1. So you want to work smarter, not harder. This is going to end up giving us positive 3x squared plus 7x plus 6, not plus 6, sorry, minus 6, because that has to change the sign too. Equal to 0. And my leading coefficient is not 1, it's 3. So we're going to have to do the A times C method for factoring. I teach it by factoring. Your teacher might have taught you, my father drives a silver Mercedes. It's the same process, okay? So if that's how you know how to do it, that's how you would factor it. But I'm going to show it by grouping. So we do A times C. 3 times negative 6, that's negative 18. B is 7. So I'm looking for factors of negative 18 that add up to 7. That would be, let's see, 9 and negative 2, right? Now we have to remember that when we factor by grouping, when the A is bigger than 1, the magic numbers are used to split the middle term. So that 7x, you rewrite it as 9x minus 2x. And then bring down your other terms. X squared plus. And once you're in this step, you have to group your terms into 2 groups of 2, right? So 2 terms and 2 terms. And you factor out your GCFs from each one. So for the first set, I can divide by 3x. So you factor out your 3x, and that leaves you with x plus 3. And then if you multiply it back in, you should get the same thing back. 3x times x is 3x squared. 3x times 3 is 9x. So you can always mentally check to double check that you did it right. All right, so that's done. Over here, I have negative 2x and negative 6. So I'm going to divide by negative 2, right? When the leading term is negative, you want to make sure you factor out that negative as well, which then will change the sign. So that would leave me with x plus 3. And then our indication that we did this correctly is that the two parentheses match exactly. So you basically bring that out front and it's your first factor. And then your other factor comes from what's left over, what they don't have in common, which is a 3x minus 2. Okay, now remember what we're trying to do. All I did right now was factor, right? But what I'm trying to do is find the roots. So now I still need to solve. So now that everything is factored, set each factor equal to 0, solve for x. So if x plus 3 equals 0, subtract 3 on both sides, x equals -3. That's one of my roots. 3x minus 2 equals 0. Add 2 on both sides, so you have to be careful. This is a two-step equation. So when you add 2 on both sides, you're going to have 3x equals 2. But x is not by itself yet, so you still have to divide both sides by 3. So then x equals 2/3, leave it as 2/3. Don't turn it to a decimal because it would be 0.6666 repeated, and that would be an approximation. But if you leave it as a fraction, it's exact. So those are my two roots. So once you find these roots, what does that mean? So I know that I have a quadratic function, so I know that I have a parabola. So if I'm just kind of thinking about the graph, I'm going to have a parabola. And these numbers basically tell me where the parabola crosses the x-axis. So I already know that one of the intercepts is at -3. And the other intercept is at 2/3. Well, 2/3 is not a whole number, right? But if I know this is 1, 2/3 is basically 0.666. So it's not going to be quite at 1, but it's going to be 2/3 of the way there. It's going to be about here. So I know that my parabola is probably going to look something like, if there's a point here and a point here, it's going to look something like this. More or less, right? It's not perfect, but what's important is that I have the intercepts. Now let's see if I'm right, like if the way I'm thinking about it actually works. So let's go ahead and go to Desmos. And I'm gonna graph this equation so you guys can see what it looks like. Now, when you graph in Desmos, you need to make sure that you graph the equation after you fixed it, so that it's basically in y equals form. So you're gonna put y equals, and then it's gonna be the 3x squared plus 7x minus 6. So once again, you put y equals and you graph the equation after you fixed it, once it's set equal to 0, okay? And you're gonna see that the parabola is graphed, so somewhat close to what I thought it was gonna look like, but this is what we're looking for here. Where it crosses the x-axis, these are my roots. So see how it happens at -3, 0? And when I solved for it, I got x equals -3. So then that means I did it right. So that's my first root. My root number 2 happens over here. And if you click on that point, it's 0.667. Well, that's the same thing as 2/3, right? So it's the same thing I got, except that in the graph, because it's a point, it gives it to you as an ordered pair and the y value 0. But my x values match exactly with what I solved for. So that's the connection between how you solve algebraically by factoring and then how it looks on the actual graph. Your x values should match. So let's say that I give you x squared plus 3x equals 0. It's already set equal to 0, so you don't have to worry about fixing it. But notice that there's no c. You're missing the constant. So you're not going to be able to factor it using the 2 parentheses the way you're used to. The only thing you can do here is factor out the GCF. So if you have x squared and 3x, 1 and 3 don't have any common factors, so you can't factor out a number, but they do have x to the first in common, right? So you can divide both by x. So when you factor out that x, that GCF, it leaves you with x plus 3 equals 0. Well, you technically still have two factors. It's x times x plus 3. So x is a factor, x plus 3 is a factor. So you still set each one equal to 0 and solve for x. X equals 0. That's already solved for, so you don't have to solve anything. So one of your roots is at x equals 0. Take your second factor, x plus 3. This one, just subtract 3 on both sides and you get x equals -3. Make sure it's set equal to 0, factor the trinomial, and then set each factor equal to 0, solve for x. And that's how you solve for the roots by factoring.